To start with, she already went through my introduction, and I think everything was covered on the slide. These are my two kids, Oliver and Honey. Honey is 10 months old and Oliver's 2.5. So whenever I'm not in school and not in the Army, then I'm with them. They are my whole life, basically. So what is a macronutrient? So the macronutrients, as I'm sure everyone knows, essentially their names: carbohydrates, fats, and proteins. So looking at the bigger picture, macronutrients are a piece that makes up our food. One second. So we care about them because two modifiable factors that make up our health is going to be our diet and our exercise. And those have a huge impact on preventing chronic diseases, or just having a controllable factor in your risk for getting those diseases later in life. So that's why we care about what's in our food. That's why we care about our macronutrients. So when you think about carbohydrates, fats, and proteins, the way that we kind of measure that is in energy. And they literally take the food and put it in this little box, just like the picture shows. And it's a measurement of how much energy 1 gram of food raises the water by 1 degree Celsius. So I always think that that's a super cool scientific way to look at how we measure food and really understanding what it is like on a molecular level. But we can think of food also as being nutrient dense or energy dense foods. So nutrient dense foods are going to be towards the right hand of this slide, and then energy dense foods are going to be towards the left hand of this slide. And in food, we not only have macronutrients, but we also have micronutrients. So they're called macronutrients because we need them in larger amounts to go throughout your day. And then micronutrients, you probably guessed you need it in smaller amounts. Micronutrients, which we're not going to talk about in depth today, but those would be your vitamins, minerals, phytochemicals, zoochemicals. A lot of those vitamins are going to be antioxidants, but we're going to focus on the macronutrients, which you need in larger amounts. You need them for energy, to fuel your day, not just exercise, but just walking, working, typing on your computer. You're going to need protein, carbs, and fats for all of those. And on a cellular level, you're going to need all of them for all of the functions that go in your body. So we're going to start today talking about proteins. And proteins break down in your body to amino acids through a really complex metabolism system that we're not going to go into today. But they are basically the building blocks for your muscles. They help with body movement. You need protein in your diet to maintain your muscle mass. You need it to build your muscle mass. And these are the amino acids that build those. So we have essential and non-essential. Essential meaning you need them in your diet, and non-essential means your body can create them for you. Conventionally, non-essential proteins are going to be proteins that within a certain time in your life or within certain diseases, they might be non-essential to you. So like an infant, for example. Proteins are also enzymes in specific processes, like carbohydrate metabolism needs proteins into that system. Insulin, for example, is a hormone that is a protein, and that helps with homeostasis in your body for your blood sugars. So there's a lot of support in structural and mechanical functions within our bodies. They help with chemical reactions, and they help with regulating a lot of systems. There is protein transporters that help move fluid around in your body, whether that be through water or blood. And even in your nervous system, there are proteins that help, that are neurotransmitters that aid in our reflexes, our senses. So they do a lot in our body. Just some random tips or facts. Muscle cut of an animal source is going to lead to a leaner source of protein. So like your sirloin, your thighs, your breast, your leg, all of those versus like the ground meats or deli meats. Proteins have a bioavailability. So that means when you eat the protein source, how much of it is your body going to absorb versus excrete out in your urine or stool. And there is a certain scale of what foods are more bioavailable that we eat. And eggs is one of the top proteins that we really consume all of the nutrients in an egg. Getting more protein in your diet can be easy if you just even get 5 or 8 more grams into each of your meals or snacks. So examples of that would be putting even a little bit of scoop of protein powder in a smoothie, adding an additional amount of egg whites into an omelet with whole eggs will increase the protein in that meal. So little things like that are small ways that you can increase protein in your meals. And then plant sources of protein will also have fiber in them. And here's a list of some protein sources. And on the left-hand side is going to be more meats and poultry. And then we'll move in to different kinds of powdered proteins that you can get. And then dairy sources of protein, and then plant sources of protein. Is anyone surprised by anything on the list for protein foods? Let me know if anything comes through in the chat.
Somebody says cricket. And then
yes.
Somebody asked, what is casein?
So casein is a protein that is in dairy, so it has whey and casein protein in it. Casein is going to be the slower digesting protein, and then whey is more easily digestible or faster, more quickly digested. Cricket protein is an interesting one, and I don't know if they still sell it on the market, but at one point they did have powdered cricket protein for, I don't know, anyone that wants to try something different, I suppose. So now that we looked at proteins, we're going to move on to carbohydrates. So carbohydrates break down to glucose molecules, and the type of carbohydrates on a molecular level is going to be how many glucose molecules are in there. So monosaccharides, for example, is 1, disaccharide is 2, and so on and so forth. So depending on how many sugar molecules are together is going to determine how quickly or slowly it's absorbed when it's broken down in your body. Polysaccharides are going to be probiotic containing foods like legumes, grains, fruits, and they contain really good bacteria for our gut microbiome. And your gut microbiome does so many amazing things that we won't get into today, but it can even influence your mood, for example. So the probiotic foods are going to contain those bacteria to make your gut microbiome more diverse. And then prebiotic foods, which is also carbohydrate, fiber, is going to feed those bacteria. And maybe a not so fun fact, but gas is actually produced in your microbiome by those probiotics eating the fiber. And that kind of reaction, gas is a byproduct of that. Carbohydrates are also going to be responsible for bulking your stool, increasing the weight of your stool. So something that helps kind of regulate your digestive system is going to be fiber, fluids, and then movement or fitness. So carbohydrates kind of fits into that as well. When you hear the terms simple and complex carbs, they're talking kind of how I said, how quickly or slowly they absorb. So quickly absorbed carbohydrates are going to be the simple carbohydrates, and complex are going to be the slower absorbing ones. Also, part of carbohydrates, we have them because they sweeten our food. So carbohydrates are our preferred main source of energy for our bodies. We run off of carbohydrates. It's the first metabolism system that our body easily transports those glucose molecules where they need to go. whether that only not be for exercise, but for every thing that you do, just sitting at work, standing up, sitting down. It doesn't have to be like vigorous exercise to be using carbohydrates. We're always using those. Another reason that we like carbohydrates is because it sweetens our food. So even, for example, added sugars in our food, they're still coming from carbohydrates. So, for example, on this nutrition label, you can see the total sugars is 16 grams, and in that includes 6 grams of added sugars. Those added sugars is kind of a myth that those would come from kind of a non like fake sugar, if you will. But even if there's honey added to this product, that's still going to be what's included in that 6 grams of added sugar. So lots of different types of carbohydrates. Just some random tips for carbohydrates. You want to aim to incorporate whole grain sources into your diet. The refined carbohydrates, if you think about a grain and it looks like a little like one single grain, inside of that is going to be bran and germ that they have removed, which have the nutrients and the fiber in the grain, but whole grains are going to have that entire thing intact. So refined grains, not that I don't want to label them good or bad, because there is still a time and place for everything. They still have some of the nutrients added in for the health of the general public, like folate and B12 vitamins, for example. And some of these have been added back in for specific reasons they've found over time to be helpful. So folate, they have added in because it will reduce your chance of having spina bifida when you're pregnant and your baby developing that in the early years. But they have found that if you supplement it early, maybe when someone's not even thinking about planning to have a baby, it decreases those chances a lot more. So that's an example of why a nutrient would be added into a refined carb like that. Having a consistent supply of carbohydrates through snacks and meals all day is going to give you energy, just the same as the proteins. And then our next source is going to be fats. Oh, and here's a list of the different kinds of carbohydrates. There's lots and lots. This slide doesn't begin to cover all of them, but it's in vegetables, fruits, grains, milks. Is there anything surprising on this list for carbohydrates? Let me know if anything comes in on the chat.
Someone says milk is surprising.
Oh, yes, there are going to be carbohydrates, fats, and proteins all in milk. And then depending on what percent of milk will determine the fat content in the milk. Plant-based milks are going to be higher in carbohydrates, like oat milk is probably one that you would assume would have carbohydrates in it. But almond milk also is going to have some carbohydrates in it. A lot of the plant-based milks. I apologize for the typo on this slide. But moving on to fats. So fats on a chemical level are made up of fatty acid chains attached to a sterol. And that probably doesn't mean anything to you, but basically when we talk about saturated, unsaturated, and trans fats, it's talking about how many hydrogen atoms are attached to that fatty acid sterol chain. So if they're covered and saturated with hydrogen atoms, you have a saturated fat. And those are the ones that are going to sit at room temperature. So they're going to be solid at room temperature. And then an unsaturated fat is not going to be saturated in hydrogen atoms, and it's going to be liquid at room temperature. And then trans fats are going to be a fat that is kind of mechanically made. So we can think of like our hydrogenated vegetable oils that is made in baked goods. Those are going to be trans fats, but we actually shouldn't have any of those in our foods now. It was like in 2018 to 2020 is the banning period of trans fats. So trans fats, if they were in our diet, would severely increase our HDL or bad cholesterol. And then saturated fats also have that same effect. But that's not to say that we take them completely out of our diet, which has kind of historically been the message, which might be a little misleading. Under unsaturated fats, there's also going to be mono and polyunsaturated fats, and that's just how many carbon bonds there are in those. So all of that is kind of chemical reaction terms that aren't super important to know. But in fats, they are a second source of preferred energy for our bodies. So at rest, when we sleep at night, we're going to be using fats for our source of energy. Our brains really want fats to kind of fuel all of those super minuscule chemical reactions that are always going on in our bodies. When we exercise for long enough, we're also going to use fats. And another kind of myth is that we kind of cycle on and off of, first we use all of our carbohydrates for the energy, and then we switch into this fat burning or fat zone. But our metabolism is really complex. It's really smart, and it adapts to things that we put it through, whether that be food or exercise. So we kind of go interchangeably within the two by the time we're exercising, between carbohydrate metabolism, fat metabolism. They're happening at the same time more than others, but we don't just go through one and then automatically are in that zone and stay there, if that makes sense. So we need both for energy. So fats help us regulate and protect homeostasis within our body temperature. We need fat sources for hormonal functions, especially if you're a woman. And like I said, for brain functions as well. Fats are found in oils, butters, nuts, nut butters, vegetables, dairy, like we talked about, and meats. So there's lots of combined foods that will have fats and proteins, or fats and carbs. But this is a small list of foods that are predominantly fat. Just some other tips about fats. So there was once thought that dietary cholesterol would raise our blood cholesterol, but that has been proven in our literature not to be correct. So you can still continue to eat as many eggs as you want, and it's not going to raise your cholesterol. What's important about fats is managing the ratio of omega fats that we consume. So typically in our standard American diet, if you consume what that would be, and maybe that's an unfamiliar term with the audience, but standard American diet is going to be one that is more of the energy dense foods that we showed in the previous slide. And those are going to be higher in omega-6 fatty acids, but we actually want to balance that ratio to have more omega-3 fatty acids for health. And then just a reminder, by creating balanced meals and snacks with fat sources, it's going to help you stay full longer. So now we're going to talk about how much of them we need. And I just want to check time. I think I'm doing okay. So how much of each of these macronutrients do we need? Each macronutrient is going to relate to a certain amount of calories. So if we look at this nutrition label, fats have 9 grams of calories per calorie. So if we look at 8 grams of fat on this nutrition label, and we times that by 9, and let me get a calculator, so I'm not doing this by... So we get 72. That's 72 calories of fat are in this food. And if we did that with all of the macronutrients, except for carbs and proteins are going to have 4 grams, then we would get that total calorie amount of 230. Does that make sense to everyone? Let me know if anyone has a question about that. So when we look at the ratio, oh, go ahead, Emily, were you going to say something?
No, I was just going to say no questions.
Okay. So when we look at the ratio, these are the ranges that the dietary guidelines have set forth to be for the general public to prevent diseases. So these are huge ranges, and it's going to depend on a lot of different factors to be individualized on where you want to fall in these ranges. So it's going to depend on your age, your activity level. Maybe you currently have an illness, then you would need a higher protein ratio. Maybe you have another diagnosis like diabetes, then you would be a lower ratio for the carbohydrates. Maybe you're pregnant or lactating, then you're going to need higher fat sources and a higher protein level. Again, one caveat to these ratios, and there's been lots of literature on this, the protein ratio that we currently have in the guidelines is pretty low for the general person, especially if you are active. So we really want to be on the higher percentage of that, around 30% for your protein intake. But because this is so individual, to know what the proper ratio is for you, it would be really important to talk to a dietitian, for example. You can kind of do a trial and error if you wanted to track. So that was one of the questions, was how do you track your macronutrients? You can track there's a lot of apps out there to track. You can track by pen and paper, just by the math that I showed you in the previous slide, and you can track everything you eat throughout the day. So there's lots of ways to track your macronutrients. What I would recommend is just getting kind of a ballpark idea of where you're at now, and not necessarily tracking every single day and being really meticulous about the numbers, because it's going to matter more big picture what you're doing. What are you doing every week? What health supporting habits are you doing every week that are going to get you in those right ratios? And really just a variety of each type of macronutrient is going to be more important to incorporate into your diet.